We proceed how to inject the which controller? Observer controller to the original system. Because I say that this is about estimation. Estimation. So firstly you have, this is for your knowledge lah. Okay, how we inject. However, at the end you just need to use the formula only. But this is for your information how we inject the observer controller to the original system. So same thing, you have original system. This is original system. Okay. So that's why, because we want to do the estimation, we also must have the estimation. The head, if you look at any mathematical expression in the papers and so on, everything with the head, this is referred to the estimation. We just estimate the value. Ax plus bu, y estimation cx plus du. So I told you that the only that we need to estimate is about x. Yeah. So if you look at the x, everything is a estimate. Okay. If our x is estimate, then our output automatically will be estimation output. Is it logic? Yeah. So that's why the input same, because the input is something that we give. So is it we estimate the input? No, because we know what we give to the system. So that's why the input is the original input. Okay? And then the A, B, C, D is same lah, because you have a system and then you do the mathematical modeling. If you still remember the electrical and translational mechanical system, and then you get the A, B, C, and D matrix. So the only thing that we need to estimate, because we don't have equipment to withstand the high temperature before, so that's why the X and Y we estimate. So now we have the estimate. This is estimate system. Okay, so what we need to do, we have the original system, we sketch the block diagram. X dot A, if we put 1 over S from X dot, we get X. Okay, and then A, this is input, B, and then C. If you understand this one, this thing we convert to block diagram. This is the block diagram. You know that? This is your X dot. The X dot equal to A multiplied with the X. Siapa pula dah? Halo? Waalaikumsalam. Dekat bilik alim, dekat lab apa ni, maklib. Dekat ICSL. Bawah. Bilik proses tadi lama tu. Boleh. Ni tengah ada kelas. Itu yang tak boleh nak pergi. Okey. Okey, terima kasih banyak. Okey. Okay. So this is X dot equal to A multiplied with the X, A multiplied with the X. This is to be plus lah. Plus with B multiplied with U. Is it same thing? Y equal to CX. So the Y equal to CX. Y equal to CX plus with, supposed to be you have D, D D plus D multiplied with the U. Okay. So this is how we convert the system to the block diagram. Okay. So this is for the original system. Then we also need to have the estimate system. For the estimate system, everything will be same because x dot ax bu, x dot ax bu kan, y cx plus du, y cx plus du, same. So the block diagram will be same. So we just put b one over s c d a, everything's are same. Because I told you that the U is coming from the same U kan. So that's why the U we connect to the original. Because they are from the same U. Okay. However, the difference is it S dot Alamak. The difference is this is S dot If this X dot, this one should be X dot estimate. That's the only difference. This one should be X estimate. The Y should be Y estimate. The rest same kan? Only for the X dot, X and Y, everything will be the estimate. Okay, I give you 1 minute to digest first. We try to finish before 12 lah, because the process are same. Betul? We try to finish before 12 because the process are same. So I believe you will know how to do it. Okay. Okay. So far we not yet inject the observer controller, because for the pole placement controller we inject K to the original system, then it will become pole placement controller. Do you still remember the observer controller, what we need to find? What parameter? L. We need to find the L. So far we not yet inject L into the system kan. So where we inject L to the system for the observer, we inject because for the observer controller, okay, for the pole placement controller we could use X. We inject K to the X, and because we can measure. But for the observer controller, we inject L. We inject L to the error value. Error value. So the error value, this is Y estimate. The error value we can get between the output of the original system minus with the output of the estimate. So this is positive, this is negative. The equation here is y of the original system minus with the y of estimation. Okay, so this is where we inject L. And then we go back to the x dot estimation. So this is the area. This is the area that we inject observer controller. Okay, this is for your knowledge, because I want to appreciate what happened during the final exam. This will not be asked lah. At least you know what's happened. The formula is not suddenly coming out in the appendix. It have derivation process. Okay, at least. Okay, is it clear? So now, everything here is a observer controller derivation. So what you need to do, for the observer, I told you that for the observer controller, we use the error value. Okay, we use the error value. The error value, which is x minus x estimation. If you still remember that, when you in lab number 2 kan, lab number 2, your output value is a angular pendulum and also angular displacement. The angular pendulum is your state variable kan, x, and also your angular displacement also your x kan. So it means that in order you just get the error lah. So that's why the error value between these two is x minus x estimation lah. So it means that for the observer controller, we use error to design. So it means that error equal to x minus x dot. If we differentiate error, you get error dot. Differentiate x, you get x dot. Differentiate x estimation, you get x dot estimate. Okay, and then based on that, you just replace your x dot here. For x refer to original system because no head. You get ax plus bu. This one ax plus bu minus the x dot estimation right now is ax estimation. Ax estimation plus with the bu plus with, there is a new thing, L multiply y minus y estimation. Okay, and then after that, we just simplify everything. Ax plus bu minus ax estimation minus bu minus L y minus y estimation. And then after that, you just put AX together. AX minus AX estimation plus BU minus BU minus L y minus y estimation. And then this can be cancelled up. The A you can factorize A X minus X estimation, is it? Minus L. Your Y here is CX. Okay? Your Y for the system is CX plus DU minus your Y estimation is CX estimation plus DU. CX estimation plus DU. And then you simplify everything. DU cancel. And then you have A X minus X estimation minus L C X minus X estimation. E dot. Since you know X minus X estimation equal to error, there you just put A X minus estimation equal to error minus L C X minus estimation equal to error. Finally, your E dot A minus LC error. It's very long. Finally, you get a very simple one. Okay. So this is the formula for observable controller.